Okay, so this question talks about the weight of an object, and it's asking you to compute the weight at different locations. So on the surface, at a height above Earth, and then at the same height above Earth, but this time in orbit. So in the first case, you're asked to find at the height equal to the Earth's radius. So this is at the distance of the Earth's radius, RE, from the centre of Earth. And then, of course, if you wanted to find the weight at that location, you take the standard value for g, which is 9.81. Of course, this is assuming a spherical Earth, which, as we've seen, is not the case. And then, timesing those two numbers together, you get just over 490 newtons. Now, going into part B, if you then consider that you've moved an extra height above the surface, you then have to increase the separation by the same amount. And because gravity is inversely proportional to the separation squared, you then have this distance here. So you have 640 kilometers for the radius of the Earth, 300 for its altitude, and then times by 10 to the 3 to get it into meters. And this number is the mass of Earth in kilograms, and this is the gravitational constant g. So times that together, you get the answer of 8.9, just a bit over meters per second squared. Now, perhaps surprisingly, it's not that much less than the value at the surface. Then you've travelled 300 kilometers upwards, but your gravity is only fractionally less, 10% less perhaps, than what it was at the surface. And it gives you an idea of how far you really have to go away from Earth for gravity to become negligible. It's really a long way, orders of 10 times the radius of Earth away from the centre of Earth, for gravity to fall, to levels below 1 meter a second squared. So once you have this, you can compute the weight at that height to be 445 newtons. Of course, slightly less than it was at the surface. And then finally, what happens when this object is now going in orbit? Well, of course, the weight doesn't change. The weight doesn't change. The weight at that height is always going to be the same. What has changed is the fact that it now has this component of circular velocity. So at any one point, you're travelling around the Earth at the same time as falling towards the Earth, and the resultant is that you stay on this orbital path. So orbit is nothing more than constantly falling towards Earth at a rate which means you effectively stay at a fixed radius away from the centre. And of course you have to have a certain orbital speed, and it's about this altitude we can show that the orbital speed is of the order of 7 kilometers a second. So you can see it really has to travel fast to stay in orbit.